quick look at your test. So for the multiple choice, there were 34 by the time one was a bad question. There were no right answers, and then one was a dud. So out of 36, there's actually just 34. You see 3 numbers across the top. The first number was out of 34. The second number was out of 26 because there was 13 vocab questions. And then the last part was a short answer. You were supposed to answer 6 of them for 3 points apiece for a total of 18. 1, 2, 3, 4, 5, 6, 28. Oh well, I think it's fine because on my answer key I have 28 at the bottom, but then on the front I have 26, so everybody just kind of, and I took it out of 74 instead of 78, but there were actually 80, so I took out 74 instead of 80. I don't know if you guys follow that, but it's in your favor. Okay, so the middle number, the maximum you could have gotten was 28. So Galveston, Texas got hit twice in the 1900s, and there it's the deadliest. Question number 2, greenhouse effect. A actually summarizes what's happening with the greenhouse effect. Energy from the sun warms the earth, and that long wavelength energy can't get back out. It's like a greenhouse. 3, solid would have the most hydrogen bonding. 4, I wanted you to tell me what the percent relative humidity is. I gave you the temperature at 20 degrees Celsius. The maximum it can hold is 14 grams of water per kilogram of dry air. This is a kilogram of dry air, and we're holding 7. So 7 is half of 14. So 5, the best answer for that was C. What causes ocean currents? And actually it's just ongoing winds over them, like what we call prevailing winds. Question 6, which is not an ingredient for the formation of a hurricane? You need A, you need warm water, you need C, a strong Coriolis force, and you need D, unstable atmosphere, but you don't need the jet stream. Actually, B, the jet stream can mess it up. Question 7, nitrogen is the most abundant gas in the Earth's atmosphere. 8, why does hail kind of look like it has layers? And so C is the best answer there. A hailstone gains a new layer as it moves up and then falls back down and moves up and falls back down. Question 9, which of these is not true regarding the Earth's atmosphere? It's not true that A, that carbon dioxide has both a cooling and a warming effect. It actually just has a warming effect. Clouds have both a cooling and a warming effect, but carbon dioxide is just one way. Question 10, which of the following is not true regarding how we categorize hurricanes? It's not true that C, that they are categorized after they hit landfall. They're actually categorized while they're doing their business. Question 11, which is said to create the movement of wind? And A, that's the motion of air from high to low pressure. 12, list the stages of a hurricane in the proper order. So you have disturbance, depression, storm, and then cyclone. So A is the best answer there. For 13, what I was after was we have these 3 boxes come from left to right, and we have the liquid water that's all in the bottom and dry air on top. You let it go for a little while, and you have some of that liquid evaporating. You go for a long time, and then actually you have the amount that's evaporating is equal to the amount condensing. So that's what we call in equilibrium. So that's what I was after for 13. 14, which of the following planets, in addition to Earth, can have water existing in all 3 visible phases? None. So Earth is the only one. Question 15, which is not one of the ways that we can have our highs and low pressure, horizontal pressure differences. And we can have converging, diverging air, temperature differences, and temperatures and moistures. Dry air actually has a higher pressure, and moist air, humid air, has a low pressure. But salty versus not salty is not the way to create a pressure difference. Question 16, which of these do we look at when trying to evaluate whether an El Nino or La Nina influence? And the best answer there is D. We can kind of look at those easterly trade winds specifically off the west coast of South America, and then on into Australia and Indonesia. Question 17, which is not one of the lifting mechanisms that we talked about? Convergent air will lift, but divergent air actually will sink. So convective lifting or graphic lifting and frontal lifting are all ways that you can get a chunk of air to go up. Question 18, which of the following is incorrect regarding a high and a low surface? So this is a hard one, but actually A, B, and C are correct about the system they're talking about. D is incorrect. A central high is an anticyclone. Tiny thing. And actually a central low is a cyclone. Which lists the stages of a thunderstorm cell from earliest to latest? You have cumulus, then mature, then dissipating. So D is the best answer there. For 20, we talked about different scales of winds with regard to their size and how long they last. Starts with micro, then meso, then macro. For 21, which of these is false about tornadoes? And B, it's false that actually, even though most tornadoes are those low ones, EF 0 to 1, they have the fewest fatality. So that the others are true, A, C, and D are true. Question 22, which is incorrect about heat index? And so D is actually just the opposite of the way it is. Heat index temperatures will be lower. Your heat index temperature, how uncomfortable you feel, will be lower at lower relative humidities. So D is incorrect. 23, on a weather map, let's say you have a front that actually has alternating red and blue triangles and semicircles respectively. That's an example of an A stationary front. Question 24, 70% of the Earth's surface, 75, is actually covered with large bodies of water, our oceans. Question 25, nitrogen is not a variable gas. Nitrogen is a permanent gas, but water vapor varies, carbon dioxide varies, and that ozone, otherwise known as ozone, also varies. Question 26, which of these phases would energy be released? And I think it's easier to think of what energy is required. So we need to add energy to melt something, we need to add energy to evaporate something, and actually A, we need to add energy when we talk about sublimation. That's when something goes from a solid directly to a gas. So energy is released upon condensation. So B is the best answer there. Question 27, why are the skies blue? And that's from Rayleigh scattering, and I tried to describe that in C because gas particles in the Earth's atmosphere, they scatter incoming short wavelength energies, including the color blue. 28, which of the following is not true about Earth's ozone hole? It's not true that C, that the good ozone hole is located in the troposphere. We could correct that and make it true. We could say the good ozone is in the stratosphere. So it's sometimes, I don't know if you're saying his head is in the stratosphere. His head is in the clouds. Question 29, thunder is the result of, the best answer there is C. The air around a lightning bolt actually heats and expands faster than the speed of sound, and it's a sonic boom that we're hearing with thunder. 30 is blank. 31, which of these has the most kinetic energy? What matters in its gaseous stage? B. 32, which of the following would be moist and tropical? Moist, we use the letter M for maritime. Could be moist, but it's maritime. And warm would be tropical. So the answer there is B, maritime tropical. List the layers of the Earth's atmosphere from closest going up. So we have troposphere, stratosphere, mesosphere, thermosphere. When we see heat lightning, it's actually because heat lightning, we don't hear the thunder, and it's just too far away. For the sound dissipates before it gets to us. So A is the best answer for that. Yeah, question 35. From what I could tell, they're all correct. So bad question. 36. Which of these is not true about the Coriolis force? It's not true that the Coriolis force deflects to the left in the northern hemisphere. Instead, Coriolis force deflects to the right. And I get my lefts and rights mixed up, but it's that way. For vocabulary words, for the first one, I was after the word recurving as what happens when it's almost like hurricanes have a mind of their own. If I got new markers, so let's see if I can. If this is our east coast, there's Florida. Okay. Of course, this is the Atlantic Ocean, we have a semi-permanent high pressure here, and in the northern hemisphere, of course, we're looking at clockwise motion around a high, and so actually that's what hurricanes do. They kind of go up and around, so that's what I was after there. Squall line is thunderstorms. They are kind of marching towards you, associated with a weather front. Question 39, and it's possible, these were all worth 2, it's possible that you got 1 out of 2. So for the next one is after aerosols, is the tiny little suspended particles suspended particles and liquids in the Earth's atmosphere. Question 40 was after the water cycle, called the hydrological cycle. Question 41, hydrogen bonds are the special bonds that connect water molecules together. Cloud condensation nuclei for 42, the little piece of dirt, that's why they say never eat snow, because actually snowflakes are dirt. Question 43, never eat yellow snow either. But anyway, Coriolis force, abbreviated CF, is what actually is caused by the Earth's rotation and affects large bodies of water and air. 44 hours after jet streams, is those fast-moving ribbons of air that are between the major cells. Latent heat was the energy associated with any phase change. Oh yeah. And I think I had you guys put a little subscript 3 here for the formula for this molecule, O3. Did I do that? Okay, good. Yes. It's called ozone. And good ozone, like I said, is in the stratosphere. Hook echo is what 47 meteorologists look for, as in kind of the pattern of the precipitation that's falling, to see where kind of some nasty weather might be. Storm surge is associated with a hurricane as the eye reaches landfall, and it's like a wall of water, kind of like when you're in a swimming pool and you're waving that water around, wall of water. Spiral rain bands is what I was after for 49. From those satellite images, you can kind of see the white tops of the clouds, making kind of, looks like a galaxy kind of to me, spiral galaxy. 50, monsoons are locations that have exaggerated precipitation fall with their different seasons, and that's related to the moving cells, planetary circulation cells. So for these, you only needed to do 6 out of the 9. So I'm starting to think about your final exam now. I can, since you've had all 4 unit exams. So I'm going to lift some of these off and kind of narrow it down, give you some extras to study, but for sure tell you what it's narrowed down to, and then just a handful of questions over Unit 5 that we've been talking about most recently. So for 51, you can kind of see the pictures I drew. Some of you guys told me in words, which was great. But basically, to get snow, it starts out as colder than 32 up in the cloud, and it stays colder than 32. For rain, it starts out as colder than 32, and then actually, as it gets closer to the Earth's surface, it melts. It's warmer than 32. And then to get both sleet or freezing rain, it starts out as snow, it melts, and then it's colder than 32 here near the Earth's surface. This is what we call a temperature inversion. For the next one, what happens to the pressure of the air as you go up? And so I kind of put thick air, thin air, high pressure, low pressure. That's a good one. That one should make it to your final, don't you think? I try to pick for your final, I try to pick ones that most people liked or, but anyway. So for the clouds, this is what I was looking for. Remember, if it's precipitating, it has the nimbo or nimbus. If it's middle, it has an alto. If it's high, it has cirro or cirrus. And then, of course, we have the stratus or flat and the cumulus or fluffy. So for A, it's precipitating, so it's nimbostratus. For B and C are both relatively low. B is flat, so that's stratus. C is fluffy, so that's cumulus. If we go up to D, actually then we're on an alto cumulus, and E is an alto stratus. And then going up to F, G, and H, we must be in our high clouds. And so F looks fluffy, so your cirrocumulus. G looks thin, so your cirrostratus. And H are those kind of mare's tails, so those are cirrus. Cirrostratus and cirrus are kind of a subtle difference. And of course you have I over there, your thunderstorm cloud, that's your cumulonimbus cloud. Oops, did you guys need this? And I will post this, definitely post this on Canvas.
Have I labeled these and you have X's by mine, but my answers don't match your answers. I think that's probably gonna go against my grade.
They don't match or they do match? Okay. Yeah, the X's mean they didn't match, so.
Oh, okay.
Yeah.
That's why I wasn't for sure, because then these ones have arrows, so I didn't know.
Yeah. These you just switched around.
Okay.
So, yep. I love the clouds. 54 was a fun one. So I don't know if I can do both 54 and the one about pressure, but so if we use these tables to find our feels like temperature when it's warm and feels like temperature when it's cold. When it's warm, we're looking at the effective humidity. So we have across the top in both cases what the actual thermometer temperature is, and for the heat index, we along the, I guess it'd be the y-axis, we have the relative humidity. So for this one, you had to take 65% relative humidity, or it intersects with a thermometer temperature of 94. It's 114. Oh my gosh. Be here before we know it. And then over here, if your thermometer reads 5 degrees, but your wind is 30 degrees, you're looking at negative 19. But again, that's only for like warm-blooded animals and that sort of thing. If you're not oozing thermal energy, it feels like 5. Okay, so your car radiator feels like 5. Although that might get complicated, I don't know. So for these, the kind of the circulation cells, the circles were the cells themselves. So of course, 1, we start out with polar cell, Farrell cell, Hadley cell, 1, 2, and 3. For 4, that's down here. That's where the 2 Hadley cells meet. That's the intertropical convergence zone. And then we go back up. So 5, this would be the surface wind associated with the Hadley cell. So this is actually an easterly trade wind for 5. For 6, that is our westerly, or sometimes called mid-latitude westerly. That's us, because we're under the Farrell cell. And then for 7, that is another easterly surface wind, and that's a polar easterly. And then we go on to this. So these were kind of what we call source regions for air masses. But the name for the source region kind of goes along with the air mass that it forms. So we have, actually A and E are the same thing because they're both over large bodies of water, makes them maritime, and they're cold. So E and A are both maritime polar. F is continental polar. B and D are the same thing because they're both over large bodies of water. They're maritime, in this case tropical. And C actually is relative unique in that it is over land, so it's continental, and it's warm, tropical. C actually, continental tropical air mass is only formed in the summertime. All right, 57 was a popular one. So A is the overshooting top, B is the updraft, C is the downdraft. Of course, associated with the downdraft, we have our precipitation and all that. Shelf cloud going out. Finally, it's like, well, that's what it looks like. It looks like a shelf cloud. So that's D. E is that gust front you feel. Notice that the precipitation stops here. So you're sitting on your porch here, feeling the wind that's leaving the storm. And then last but not least, we have the anvil up there. Anvil is, you can't see it here very well, but it's kind of a little bit of wispy cloud that's bumped up against the end of the troposphere. Here, this is kind of reminiscent of lab. That was fun. Dot to dot. So these are, of course, isobars. You connect them, and you're going to see that you have a high pressure over here, and a central high pressure over here, and a central low pressure over here. Like 2 eyes looking at you. And then for this last one, I wanted you to give me at least 3, or list 3, rules associated with naming hurricanes. Each ocean basin has its own. We alternate male and female. Some letters are just too darn hard to come up with names. If we run out, so we don't use those letters the alphabet, we run out of letters of the alphabet, we'll go to the Greek letters, which we did actually in the year with Katrina, because we had Hurricane Wilma. So we like totally ran out of letters, went to the Greek alphabet. The next one, we recycle them, which is good of us, every 6 years, so we have 6 lists. And names can be retired if they were particularly nasty. So, very good. 4 down, final to go. So let's see, this time next week, we'll be in finals mode. I can't believe it. Well, we have a little bit of learning to do between now and then. Excited about, I'll go back a little bit. I'm excited about lab on Thursday because we're going to talk about rocks. And I don't have it entirely, it's in my head a little bit, so I don't have it entirely figured out, but so I think it's going to be fun. And I do have extra copies. We did this slide, right? Okay. So we're going to kind of pick up where we left off. In some cases, there's not a whole lot to add. I'm like, well, that makes sense, right? Okay. The different types, these are our plates. Remember, plates are chunks of lithosphere that are floating around on the asthenosphere. I love saying that word, asthenosphere, which is the ooey gooey part of the mantle. So we can see some of the kind of the ooey gooiness coming up right here as these plates diverge. And remember, and boy, that was a young Bill Nye, the science guy we watched the other day, with seafloor spreading. This is actually what this is, seafloor spreading. Can you do this slide already too? Thanks. Okay, so the plates are moving away from each other. Okay, the liquid ooey gooey part will rise. An example of where this is happening is the Mid-Atlantic Ridge. And I'm going to add the word, because Sally sells seashells down by the seashore. That's what I think when I ever say seafloor spreading. You're like, really? Okay, so this is seafloor spreading. Floor spreading. All right, so they can move away, they can come together. So we have some possibilities here about them coming together. The word converge means they're going to move towards each other. And old crust will be destroyed, but it kind of depends on if they're subducting or not. And I have a word to talk about. I'm going to talk about subduction. I think one of the videos we watched on Friday talked about subduction. Subduction just means one goes under. Okay, so in cases where we have subduction going on, the material that's going down is going to heat up again and it's going to liquefy. I just think that is so cool. And it liquefies and it just joins the gooey gooey. It almost sounds like science fiction, but it makes sense. So 3 possibilities. Now, when I say continental, that means land. We could actually have a land plate and an ocean plate coming together. And I think I have a picture coming up here to show you about that. Alternatively, we could have 2 ocean plates that are coming together. It happens. And then I guess the third scenario would be 2 continental plates converging. So continental oceanic plate, oceanic plates, continental plates means 2 of them coming together. And when we looked Friday at a map of the world with, like I said, it kind of reminds me of Frankenstein, where they're all kind of stitched together. You know, they're moving. And remember, we talked on Friday that they could be diverging. Example C4 spreading. They could be converging. And the other one is going side, we call transformation. So those three different possibilities. Okay. So I have a little video to show you, but can you see where this is the first scenario where we have a continental plate here on the right and an oceanic plate here on the left. So the word is denser up there at the top. Oceanic plates are denser, and that's actually something we talked about on Friday. Dense things sink, so they'll just naturally want to be the one that subducts down, and you can kind of see that it's melting here and creating kind of a hot spot here of mountain ridge building. So the word is trench here on the second one. So we have these, if it's, in this case, we have an oceanic trench. And this, to me, I talked the other day about if you've gone both on the West Coast, out and walked down the ocean, and the East Coast walked down the ocean. The West Coast is beautiful, by the way. But the ocean, yeah, a little cold. And a little crazy, a little, yeah. So it's got a steep drop-off. And I'm not saying, like, if you go out on in Washington or whatever, California, and step out into the beach, you're going to fall off. But it gets deep pretty quickly. So let's take a look at that video right quick. Thing. So we could have an ocean plate converging, and that's what's kind of shown here. Let's see what we got. Volcanoes. So two oceanic plates converging. And you're like, well, I see subduction here, but they're both relatively dense. They are both relatively dense, and you do see subduction here. So one of them gives in. Wonder if the one that's going to go down is going to be the one that's farthest from land. Kind of makes sense because you have a little bit of lightness over here. So that's kind of what they're showing here. The word is plate. Oops, sorry. So islands actually can be kind of formed along kind of a hot spot that's created by the friction of the subducting material. The last one is two continent plates converging. Remember, continent plates are less dense, so you still have some options here. Okay, so, you know, which one's going to give in? Well, in this figure, we see the Indian plate kind of going down, doing subducting, but it's not the same as the subduction we saw with the oceanic plate. It resists that. Sometimes what happens, or actually what happens even if it does go down a little bit, is we see this pile up. Isn't that cool? I just think that's so neat. And the time frame that these things happen, though, you know, hundreds of thousands of years. So let's take a look at this video. About diverging, and if you're like me, one thing I didn't talk about was I talked about C4 spreading when two oceanic plates are diverging, but what about when two continental plates are diverging? What does that mean? I don't know. I don't have an example here. It makes me wonder. So spreading apart, coming together, and then this is sliding against each other. So when two plates slide past each other, we call that a transform boundary. In this case, you don't have any sort of destruction of the crust, whether it's subduction and it heats up and liquefies, or whether it's just kind of crunching together like we saw. And actually, these are what's most going to give us, and the word is, I think, movement and jerks. We're going to talk in the last part. There's only 2 parts to Unit 5, so we'll probably knock it out on Wednesday, so we'll have to see what we want to do. If we knock out the last part for lecture on Wednesday, I'm kind of leaning towards Friday doing the review session in here, so you won't have to watch the video.
Then if you came on Friday, I'm just thinking out loud, then if you came on Friday, then you could get like review video points for coming. I'm leaning towards that. Because I want to talk a little bit about earthquakes in the last part. But earthquakes happen when, they can happen otherwise, but with this sort of situation. I have a couple videos to show you.